So this is a 400 session, which is ideal for when we're about to wrap up the day. And what we're going to do is take a look at some of the inner workings of ASP.NET MVC, how it works, and we'll go through the different stages. And I'll try and follow up everything I say a little bit with demos. Hopefully it won't be too deep dive or 400. Well, let's just say it's 300, okay? That's fine with you guys? Yeah? Good. So, agenda. We're going to go through all the different pipeline. We're going to take a look from the routing down to the controllers, and then from the controllers we're going to go and hit the actions, and from the actions we're going to hit the views. Now, if you've worked with ASP.NET MVC, you know that one of the great features that it has is that it's very extensible. So it has a lot of extensibility points which allow us to plug in our own mechanisms or our own functionality or override the way it behaves, which is great if you're trying to do convention-based programming. So a lot of times when you're doing programming with ASP.NET MVC, you constantly have to repeat the same things over and over again. You constantly have to repeat the same infrastructure process, etc. Now that's become partially easier with NuGet, actually extensively easier. But still there are places where you're not really happy with the way MVC behaves, and let's look at ways to change that and see what we can do with it. So just to recap, when a request comes in, it goes through this mechanism called the routing mechanism, which is part of .NET SP1, .NET 3.5 Service Pack 1, which is the system web routing. It's not actually inside MVC, it's a separate DLL, which allows people that are still stuck in web forms, which is not necessarily a bad thing, to leverage routing. Once it goes through the routing mechanism, it goes and fires off these controllers, and then it goes and optionally, always executes an action, and then optionally it can talk to the model, get some data or send some data, pass it back to the view, and display to the user. Okay? When we come to the routing part, the first thing that comes in is the system web routing. And that fires off an iHTTP handler, which in our case is the MVC HTTP handler. So internally, that's what's happening. Now that gets some root data associated with it, which is information about like the path, the URL, the parameters, etc. that are passed in, and that's all done by the system web routing, as I mentioned. This is what a new route looks like. I mean, outside of MVC, this is how we would work with routes. You would define a new route, and in that route you would define the URL, you would define some certain values which are the default values, then some constraints, data tokens, and then you would delegate that off to an iRoute handler that would actually execute the route or the outcome of that route. Okay? Now, when we're talking about ASP.NET MVC, a lot of times this route handler ends up being the same thing, which in our case is the MVC route handler. So up there you see that I have an MVC route handler. That's the guy that is always executing when we're executing an ASP.NET MVC application. So here already there's an execution entry point where if we don't want to, we don't have to execute an MVC route handler. So we can use the system web routing to fire off our own process or do different things. But in the majority of times, we do want the MVC route handler, and that's why what MVC actually does is define some extension methods to route collections, which allow us to easily do the route mapping. So when we go to the code and you see this guy over here, so map route there, that is actually an extension method which always fires off an MVC route handler. Okay? So what about these routes? It's a route table. It's an ordered table. So things that come at the top take prevalence over the ones that are at the bottom. So if you have, for example, constraints at the lower level and there's a route that matches at the higher level, it's not going to fit your constraints. Anything that is more restrictive always has to be at the higher entry point of the route because it's read from top down. It's also used to generate incoming and outgoing routes. Right? So when I receive a route from MVC, it parses it out and it eventually finds the controller and finds the action and executes the action, but also it's used for generating outgoing routes. So for instance, when I do HTML.action link, what it's actually doing is looking up the action and the controller that we're specifying it in the routing table, and based on that, inversing the process and generating the URL. Okay? So you can use it for both incoming and outgoing, which what MVC does. And you can apply constraints to it. Now, how many of you have ever applied regular expression constraints to routes? Pretty sure the majority of you, right? You can take a route and you can add a regular expression to it. So let's, for example, say that I want a route to match a certain date, that it's always the format is year, 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 dash, month, month, dash, day, day. You can do that with a regular expression. If you cannot do that with a regular expression, the next step is to use the iRoute constraint, which allows us to define a custom behavior to say when a route should be matched, right? Now we can use that for different things. I'll show you a couple of demos here. This one is just a simple parameter route constraint. So what I'm doing is I'm taking the route that I'm defining, in this case it's called the constraint, which can have any name. I'm defining the pattern, which is controller action ID, the defaults, which is home, action, custom, and the ID blank, and then I call this guy, bada bing, I can call it whatever I want, and define a new constraint. And this guy over here implements an iRoute constraint, okay? So this iRoute constraint, basically you implement a method called match, and this matched simply returns a true if the route is matched or false if it's not matched, right? So here in this case I'm saying that if it's an incoming request, then the route is matched when the ID, the parameter that I'm passing in, is of length 5 or greater. Very simple process to, just to check that, the parameter length is greater than 5 or whatever. The actual output of this application, I think, it should be using route debug, so it will. You guys know this one, right? This is a route debug assembly that Phil Hack wrote, which allows you to debug your routes visually, so you can see them on the screen of what's coming. Instead of actually executing your application, it overrides it and prints out this information. So you see that here I have the default route controller that's being always matched, and then this one isn't being matched. And if I would do, for example, home, custom, and then 1, 2, 3, 4, that would remain to be false. If I do 5, 6, that would change to true. Okay? So very simple. All you need to do is just implement an iRoute constraint. Now, obviously this example has very little meaning, but here's a more significant example that might add some value. How many of you are familiar with the concept of REST, or representational state transfer? Right? So MVC is a great framework to do REST. And the problem is that a lot of it is tedious. You have to do things over and over again. So for instance, in this case, what I'm doing is using the routing table to define my REST routes. So instead of when I create a customer, I go to customer/create, and the URL is actually have a create as a suffix. What I do is just, instead of that, I just do customer with a put verb. So when a put verb comes in, then I associate that with the routing constraint. Okay? And that's done via the HTTP method constraint, which what it's doing here is just checking that the incoming request, the method that's being used, corresponds to the one that I want to be used. So for that simple scenario, for that routing entry, I say that I want, for instance, the customer details to be routed to the action details, and the constraint should be get. So if someone now types customers with a put, this route over here would never be matched because the routing constraint doesn't allow it. Okay? Now this is one way of doing REST in MVC. The problem is that that table starts to grow and it's not maintainable, because as we start to add more routes, you have to do this for everyone, right? The alternative is to put attributes on the actions, which also is not really maintainable. And if anyone is interested in doing REST without having to do all this, there is a project called Easy MVC, which I've done, which basically automates all this, but it uses the same methods that are shown here. So the constraints in routing are good In terms of parameter matching, often they serve little purpose because, yes, they prevent the invalid parameter to be routed to an action, for example, an invalid date to be routed to an action. But if we don't remove the default catch or root, then it makes no sense. Because even if we put a constraint with a regular expression and we leave the default root, it's just going to go and catch all on the default root. Okay? Once the root has taken effect, it then goes over to this other guy, which is the MVC root handler, and then it fires off this thing called the controller factory. Now, how many of you have worked with the controller factory? Okay, the controller factory basically is the guy that's responsible for creating our controllers. So when the root information gets some data, like, for example, home controller, when I type home/about, the home is created, the home controller is created by the controller factory. Now, in previous versions of MVC, up to MVC 3, what you had to do if you wanted to create your own controller factory was implement an iController factory or override the default controller factory, which is called default controller factory, and then you would implement the get controller instance. Okay? Normally you would do that. You should actually do that in probably 99% of the application, if not 100% of the applications you write. Why? Because if you're doing anything like inversion of control or dependency injection, you're familiar with dependency injection, right? Yeah? Good. So if you're doing dependency injection, which you should normally do, you always end up having to create a controller factory, which basically ends up being a copy-paste operation from one project to another, right? Now, in MVC 3, what they've done is they've implemented a new class, which is called the iController activator. And so the problem with the iController factory was that it was creating, so what is a factory? I mean, a factory is a pattern to create objects, right? I create an object. The factory knows how to create an object. So what MVC2 was doing was creating these objects, but it was doing a little bit more than just creating objects. It was also doing the type caching and a whole bunch of other things. Now they've delegated the actual creation of the object to another class in MVC3 called the default controller activator, which implements an iController activator. You can't get access to that class. It's private and it's nested. I mean, you could if you really wanted to, but you wouldn't want to. Okay? And all it does is just fire off create instance ultimately. But it doesn't do it directly. If you notice, it's doing it through this thing called the dependency resolver, right? And what is this dependency resolver? So this is the new thing that's come out now in MVC3. Whereas with iController, we would do the the controller factory is now implemented via an iDependency resolver. Okay? What is this iDependency resolver? Now, again, this is a discussion of, is this good, is this bad? Pretty much, it's a service locator. Now, it could not be called a service locator, it could be a resolver, it's called a resolver, but ultimately, that's the kind of pattern that it's following. What it's doing is finding services for you. So, in MVC2, if I wanted to create my own controller factory where I could implement my own IOC container that would resolve my controllers and create my controllers, in MVC3, that's not the approach to take anymore. What we do is we implement an iDependency resolver, right? Which basically has two main methods, get service and get services. And get service gets a service that's registered as called by the team singularly, which means that there's only one instance of that service. Whereas get services is something that can have multiple instances. For instance, filters can have multiple instances. Okay? So in MVC2, we would create a controller factory, then set the controller factory to be ours. In MVC3, the correct approach is to implement a dependency resolver and set the dependency resolver to be ours. That's why here, in the code before we saw, over here, you see that it's trying to get the current dependency resolver. And the dependency resolver is then the one that's going to create the controllers. Okay? Why would I do this? Why would I why would I not implement the way that I've been doing in MVC2? Why not just implement the default controller factory, override it, do things like that? Well, one of the advantages with the dependency resolver is that it's also hooked into other parts of the framework. So that means that, for example, if I want to inject some services in my views, for instance, which again, I'm not recommending you do, but if I wanted to, I could use the dependency resolver as well, because it's consumed from different points of the MVC framework. Okay? So that's the right approach to take from now on in MVC 3. Excuse me. So let me just show you an example of this guy. So here we have the default ASP.NET MVC application, and it's just got one new class, which is the structure map dependency resolver. Now, why is it structure map? Well, because that's the IOC container I use. So if you use Unity, you would normally create a Unity dependency resolver. If you use MEF, you would use a MEF dependency resolver. If you use an inject, you would use an inject, right? And basically, this is a typical implementation of how the dependency resolver works. So in my structure map dependency resolver, I'm injecting my container, right, using dependency injection. And my container is my IOC container. So in this case, it's structure map. Now, inside that, then I have two methods, the get service and the get services. And all that's doing is just delegating the resolving of that service to my container. So this is boilerplate code. Pretty much any IOC container you use, more or less has the same exact code, right? That's why you don't even need to do this anymore, because you can use something like NuGet, which I'll show you in a second. The only other thing you need to do is if we go to the startup application, and down here, we see that whereas before we were using set default controller factory to current and then set it to ours, in this case what we're doing is saying set the dependency resolver to this guy over here. Okay? I'm guessing everyone at the back can read the code, right? Yeah. At least one guy's awake back there. Okay, so this is boilerplate code. Now, how many of you have heard of NuGet? Okay. So I'll create a new application now. Just a default guy. So let's just pin this guy over here, and we'll get the package manager up here, and we get nice little errors, which don't know what those are about. Why is this having some packages? Okay, so now if I want to now, from now on, whenever you want to use an open source library, or any kind of library, you should just use a NuGet package, right? Never go download it anymore. So I could do, for example, install package, and then I would put structure map, okay? And that would install structure map for me, and it would then allow me to go and create my structure map dependency resolver or copy paste it from somewhere, and then set it up, right? Now, there is another package on the NuGet repository, which is structure map-MVC3, right? And if I have a decent internet connection, this should pop up, which apparently I don't have a decent internet connection. Someone said this is Belgium. Right, MVC3. Okay, so you see that pops up. And if I hit install on that, what that's going to do is download structure map, but it's also going to download some additional files that it's creating. And it's going to write the file for me, actually code out the file that I need for my dependency resolver. Okay, so now I have some folders here, which is the dependency resolution. And inside there, I have my structure map dependency resolver, which is what we saw before, pretty much the same code. Okay, But I also have an IOC, which is my IOC container configuration, which I also have to do manually, because that's something that you have to do each time, set up your IOC container. But it's also created for me, set this to start up. So I don't have to do the set dependency resolver. But if we look in the MVC application, we see that it's not there. Okay? There's no code in there to set up the default controller, set up the default dependency resolver. Why is that? Well, because imagine if every time we download a NuGet package, they're going to start to spit code into our global MVC application. It can kind of get dirty, right? And unmanageable at some point. So what David Ebo did was create this concept of an activator, or a web activator, which kind of takes, it kind of links in before your application starts. So it's like the same concept that we have with MVC application start, we can now put those in the web activators. And this is the web activator for structure map. Well, for any container, setting the dependency resolver, right? All it's doing is setting that line. The advantage to this is that if other NuGet packages use this same mechanism, they're not going to mess around with our MVC application. As new packages that have to interfere with MVC are added to our system, all they do is just add another file under the app start folder with the code that they want to set. And this is a good practice for you guys to do as well, because it makes things manageable. Now, if you've done any kind of IOC container apart from just dependency resolution, this might sound familiar to you. Because a lot of times, and if time permits, I can show you some code, what I do is I have this concept of called an interface, which is an iStartup task. And then every time I have something to do at the beginning of the application, I implement the interface. So I do, for example, database setup that implements iStartup task. User configuration that implements iStartup task. And then I have my container find all instances of iStartup task and then run a method execute, right? It's like a pluggable behavior. I can just add new classes, and as I have to do startup things, I just add new classes. This is the same concept, but not relying so much on an actual IOC container or on you having to implement a certain thing, but baked into the MVC framework, okay? So if there was a minor excuse of, you know, my application is too simple for me to use an IOC container, that excuse has now disappeared, because you don't even have to write it. You can just do a NuGet install package, and I'm using, as I said, structure map, but these web activators exist for other projects. I think there's one for Windsor, if you're using the Windsor IOC container. If you're using Ninject, there's one for that as well. I think there's also one for AutoFac. So it's very easy to do. So that's one of the extensibility points in MVC3. Whereas before it was just the iController factory, now it's the iDependency resolver. But it's beyond just controller factory, because we can now use that dependency resolver in other places sprinkled out through the framework. So we go from the routing. We've now seen how the root data is obtained and then passed over, creates a controller factory that then creates our controllers, and then once that's done, it goes to the controller action invoker. And the controller action invoker is the guy that executes the actions on our controller, right? And it takes care of finding some methods, binding parameters, executing these things called action and filters, and doing the rest of the work, okay? So the iAction invoker, again, notice the I here. So everything we're seeing, iRoot handler, iHTTP handler, iController factory, iDependency resolver, iAction invoker. What are these? These are extensibility points. These are places where we can override the behavior of MVC and plug in our own things. Here it's exactly the same. We have the controller action invoker, and we have the async controller action invoker, which is for asynchronous controllers. These The controller action invoker, default one, executes filters, then actions, and then some more filters. Action filters. You've used these. HTTP post, get, put, delete, action name, authorize, output cache. All of these are typical. I mean, all ASP.NET MVC applications have them. You've used them at some point in time. How do you define them? Well, you can define them mostly using attributes, as we've seen. In MVC 3 now, there's another concept, which we'll see, which is the global filters. And they're basically based on 4 filters, which is the action filter, the authorization filter, exception filter, and result filter. There are also events, so you can implement them via the on action executing, on action executed of the controller. Right? These are other ways of implementing it. Now, in MVC 3, we have the concept of global filters and filter providers. And these are 2 good things. The global filters allows us to define filters at a global level, as the name suggests. The advantage to this is that we don't have to remember each time to add filters to our code. So for instance, the handle error. Nearly all our controllers, all our actions have handle error, right? We add them all the time. And what happens when we create a new controller and that controller doesn't add the handle error attribute? Well, we forget. Right? And what we want to prevent in programming is every time we do one thing, have to remember to do another thing here, and another thing here, and another thing here, right? We don't have to remember how to automate processes. That's what computers are for, okay? So the global filters allow us to avoid having to remember to add filters to something that handles or is applied to all our controllers and actions. If we look at the code to the MVC application, we see that now, actually if you go to the home controller, you see that there's no handle error. Before we always used to have the handle error here, right? Which was the handle error filter. That's no longer there. I go to MVC application, and I have this concept of global filters down here, right? Register global filters. Very similar to register root tables. Now I have register global filters. And what that is just a list of global filters that are applied. In this case, it adds by default the handle error attribute. So now handle error is across our entire solution, completely. Okay? But the filters we can use to create our own kind of behavior. So let me show you a couple. Now this example is kind of preventing dry, which is don't repeat yourself. Don't do the same code over and over and over again. It is not perfect for every scenario under the sun. But a lot of times we push ourselves to the limit to try and cover every scenario under the sun, and really we don't need every scenario. Here's a typical customer controller that gets some data and displays the data, right? So here's a typical code you see. Get customer by ID, if customer is not null, return the view, if it is, throw some exception, resource not found. Okay, we've done that over and over again. Here is another example. Customer service, get customer by ID, if the customer is null, resource not found. Throw new resource not found, view customer. What is resource not found? That's just an action result that implements the execute result and returns an HTTP exception 404. Okay, so I go to a customer, 12, it's not found. So I return a 404, which is great. If you're doing REST kind of things, this is great. This is exactly what it's meant to be. A resource, a customer named John, a customer by ID 220 was not found. It's a 404. Okay, so that's just a little class wrapper that throws an HTTP exception. In MVC 3, you now have a couple of these built in. So you don't have to do this manually. You can actually throw a resource not found, I think it's called, something similar. Let's go back to where we were. So here, what I'm doing is just saying if customer not null, throw resource not found, same procedure. But constantly, if I have to do this, I have to repeat myself over and over again. So here's another example, another way of doing it. Here I do var customer services, get customer by ID, return view details customer. There's no if. There's no if the customer is not null, then display it, otherwise don't display it. if we go to the handle resource not found, I'm implementing an action filter attribute, and I'm overriding the onResult executing. So the onResult executing is a filter that takes place when the result is going to be executed. We have 4 filters in an action. On action executing, which takes place before an action is executed. That's where things like authorization filter are handled. We have on action executed, which takes place after an action is executed. Then we have on result executing, which is before a result is rendered, a view is rendered, or result, whatever the result, and on result executed, which is after. So what I'm doing here is I'm saying, if this is a view result, and it has a model, and it's not null, then take your course. I don't do anything. I don't interfere in the pipeline process. If it has a model, if it doesn't have a model, the model is null, then throw a resource not found. Okay? So leveraging the filters to kind of eliminate dry. Now again, this doesn't apply to every scenario. Right? If you have objects that have objects linked to them, which normally you shouldn't. I mean, very rarely do you have objects that at the same time have objects in views, because views should be mostly represented as a view model, so it normally ends up being a flat thing, unless you have, for example, a list of addresses or something like that. But for the majority of scenarios, it kind of works. Okay? And it avoids having to write boilerplate code over and over again. Okay? The other thing we can do is, for example, the authorization. Now, out of the box, ASP.NET MVC works with cookies or form authentication. If we want to do HTTP authentication, which again is something you would do quite a bit if you're doing REST-based services, there is no direct support for it. But we can do that again easily with filters. So in this case, I have a HTTP authentication filter, which now I'm using the on action executing. And I'm saying, the way HTTP authentication works is pretty simple. The client sends a request, and the server responds with an authorization, saying www.authenticate, this guy over here. If we go down, this is what the server responds, with a 401 www-authenticate. So the client now pops up the dialog box that you see in browsers. The user now enters a username and password, and then hits submit, and the client sends back the request to the server in a header called authorization. The header is very secure. It's base 64 encoded, and that's why they say that if you're doing HTTP authentication, you should normally combine it with SSO. It takes the header, it decodes it. In my case, it's decoding it from base 64 string, and then you have the username, password. So in this case, I have the username and the password. And then you run this through your logic, which in this case is just very simple. If username equals password, let the guy through. I set the Windows identity, the .NET identity, because this hooks into code access security. Everything fine, and it's done. Okay? And now I have complete integration with ASP.NET MVC. So I still have the username, I still have everything. To use this, I can go, for example, to admin controller, and you see that I have HTTP auth, just an attribute. Instead of authorize, I have HTTP auth. So if you run this, you should get an authorization request on the admin panel. See, on the home, it's fine. On About Us, it's fine. I go to admin, and I get the username and password pop up. So I can put Hadi 1, it doesn't work, and I put Hadi, it works, and it's done. Okay? So again, very easily with one action attribute implemented once, and now we don't even have to add it here. We could just, well, if the whole site is authenticated, you would add it to the global filters. We can do authorization. Last but not least, another usage of filters is with media types. So representational state transfer, or REST, has this concept which is very important, which is the representation of resources. And those representations could be in different ways. So I can have a customer that's represented as an image. I can have a customer that's represented as a JSON record. I can have a customer that's represented as a view. And often, the clients send headers to the servers. So they say, for example, give me back customer 20 with application/JSON in the content type. What that means is that the server should now take that data, take that request, take the customer, and encode it in application JSON and send that back. The wrong way to do that in ASP.NET MVC is to have multiple actions. You shouldn't have an action which is get customers view, get customers JSON, get customers image. The right way to do it is using action filters or custom action invoker, but somehow intercepting the process so you only have one actual method, one actual action that returns that customer. And then based on URL extension or based on the browser header or whatever you want, whatever criteria you want to use, then do the content negotiation. So here I'm using on action executed, and this is really horrible code, so please forgive the ifs. I would say this is just, I'm trying all the different options. So I'm saying if someone passes, for example, extension, so I say, for instance, customer 25.json, if they pass that in, then you've got the extension, and based on the extension, encode the data. What is encoding of the data? All it does is just, this is a simple JSON encoder, and what it would do is see if it's a JSON, and if it's a JSON encoded as JSON. Now, you wouldn't do this with if statements. You would use a kind of a pluggable, discoverable model, and it would pick the decoder or encoder based on what's coming in. So this is the right way to kind of do content negotiation in MVC2. Again, leveraging the action filters, okay? The disadvantage to global filters, as I said, is that it's great that we can now add a global filter and it will be present in our entire application. The disadvantage, of course, is that it's present in our entire application. So what happens when we want to do, for example, things based on requests? Let's say, for instance, when a request comes in, based on the IP, I want them to be allowed through or not. And that could be applied, for instance, to all my actions and routes. Or it could be applied based on a certain time interval. How do we get access to that? Those are done through filter providers, which are now available in MVC3. Okay? So what the filter provider allows you to do is just, it's a normal class, it's just the iFilter provider that you implement, and you get access to the controller context and the action context. So having access to all that, you know what action is being executed, you know what controller is being executed, you have access to the request, so you can get things like the user agent, etc., and based on that, make a judgment call and implement, have a filter activated or not. Right? That's a very powerful feature that's been added now to MVC3, which is the best of both worlds of having attribute-based filters because of the selection criteria and having global filters, which we don't have to remember to do things over and over again. Okay? So definitely, that's something that you should be playing with in MVC3. So, here's a, how would you say, a kind of debate going on, right? In ASP.NET MVC, you know that we have the controllers, and the controllers have the different actions. So I have create customer, delete customer, get customer, etc. So how many of you have heard of the concept of SRP, or single responsibility principle? Just give a loud yeah if you have. Yeah, right. So as you start to do, applications in ASP.NET MVC, your controllers can start to grow, right? You start to get like 6, 7 methods in a class. And we always say a class should do one thing and one thing alone. Right? That's what single responsibility says. And of course, we're using good techniques like dependency injection. As such, if we're using dependency injection, what do we want to do? We want to inject our dependencies. So we now have controllers with constructors with 7 or 8 dependencies. And that's a code smell, right? Why am I injecting 7 dependencies or 6 dependencies or 5 dependencies in my controller? Why? It's a sign that maybe my controller is doing a bit too much. But how can you handle that? You can't. In MVC, you can't. You can't say that, you know what, I want to have 2 methods of customer controller in this class and 3 methods in this class. And please, nobody suggest partial classes, which are blasphemy. Okay? So, yeah, along with regions. So, how can you do that? You can't. You really can't. Unless you pull out the entire pipeline of MVC and replace it, you can't. But if you think about it, really, that's what we would ideally want to a certain point. I mean, yes, a class has to have cohesion. So a customer for CRUD operations, you could say a controller has a kind of cohesion, so it would be okay to have, you know, the create, read, update, delete. But a lot of applications go beyond CRUD. They go about processes, right? Add item to shopping cart, delete item from shopping cart, process shopping cart, register this, register that. And then these are where all the different dependencies come in. So one thing you could do is completely rip apart the MVC framework and create your own controllerless actions. So you have actions which don't have controllers. So when you do customer/details, there is the details, but there's no such concept of a customer controller. Now the MVC kind of needs that. So how do I override that? Well, there's multiple ways. One way is using custom action invokers, right? So we get the controller and then from that parse it and then fire off controller, a specific class, etc. The problem with this is that there hasn't been an ideal solution that's appeared yet. Because doing this, although it gives you the benefit of being able to apply single responsibility and having very small classes, you lose a lot of the goodness that MVC provides you. Okay? So I'm just going to show you a quick code sample of controllerless actions on some sample project that existed, but it's not really ideal. So this is a custom controller invoker. And what I'm doing is just, in this case, overriding the controller action invoker, which is the default one. And this has a whole bunch of methods, right? And if you want to override the members, you see that you have find action, get parameter values, invoke action method, a whole bunch of things. Another thing of, you know what? Maybe this class, controller action invoker, is doing a bit too much as well. And what happens now is, if we want to override behavior, we have to plug in code in multiple places. That's why you get all this code here. Because a lot of it is just pretty much a copy-paste of the default action invoker, but with some intercepted things, right? But that's why you get so much code to just override a custom action invoker. That's one reason if you would want to plug in your own action invoker. Another reason, for example, would be to do the content negotiation. I just showed you how to do content negotiation using action filters. You could actually do it using also custom action invokers. So you could just get the request and based on the values that it's passing in, render out the results. Because this custom action invoker is the one that executes the filters. So you have access to that process before the actual filter has been executed. The disadvantage to this, of course, is what? That when someone uses it, if you do this, every time you have to remember to override your custom action invoker. Your default action invoker with your custom one. But of course, now with the power of NuGet, you can combine that, create a package, create a web activator, which does it for you. See, NuGet is really good, but not only for using it to download third-party libraries, but also in your own offices, in your own companies. Setting up a NuGet server, creating your little pluggable modules, and using them. I think Scott probably will be talking about that tomorrow, so it's a very good solution. So once the action invoker does all its thing, then we go to the whole process of returning data. And you've all leveraged all these types, right? There's not only action result is the base type, and then under action result we have the content result, which is for sending files over. We have JSON, which is built-in serialization of any object directly to JSON, partial view result, redirect to root, view result, a whole bunch of things. And now you can create your own HTTP resource not found result, 302. I think there's actually a moved result response where you can just send back response headers of which is HTTP result headers. Okay. In terms of bindings, this is an interesting one because how many of you know that you can override the binding behavior in MVC3? Yeah, not a lot of people. Why? Because there's really no need. I mean, I've seen a lot of solutions in projects where they've created this sophisticated model binder. And there really is very little need to create your own model binder unless you are trying to decode some format that is not supported out of the box. So built into MVC, you can actually, there is an entry point where you can create your own model binder. The model binder is the guy that takes the data from the form and binds it to something, to some parameters that are coming into the action. You can override that. But the default bindings, the default model binders have support for objects and objects that have nested objects and objects that have nested objects that have nested objects and rows of objects. So there's very little reason for you to override it. Before, in MVC2, you would override it, for example, if you wanted to bind to JSON. That's already built in MVC3. So now you can send JSON from the client and have your object as a parameter on your action, and it will automatically decode it. Okay? So iModel binder is an extensibility point. Very little reason to use it. So if you're starting to define your own model binders, take a step back and think what exactly you're trying to solve. What is the problem? Maybe you're just barking up the wrong tree. Okay? Then in validation, we have the model validator provider, which now in MVC3, again, uses the dependency resolver. So this is another extensibility point, which I'll show you an example now in a minute. And we have the iValidatable object. How many of you have heard of this guy? iValidatable object. Right. It's an interface that allows you to validate objects. So by default, validation in MVC is how? You create a class and you create your attributes and you put required or email, etc., right? The iValidatable object is an interface you implement which has a method, which is validate object, which allows you to globally validate an object. So if your object has a complex business rule validation scenario, you could implement the iValidatable object. Okay, I'll show you a quick demo of that. So here I have a customer view model. This guy over here. And no, actually, customer view model, right? So it implements the iValidatable object. It has a method called validate, which takes in the validation context. We can go through all the members, do whatever we want, get information from the validation, and pass back information. So that ties in nicely to model state. If you're using model state, you can push back information there, and you get complete object validation if you need it. Okay? Of course, this is not going to work on client-side validation unless you hook it up on the client side as well. Okay? But normally, this is for more complex scenarios that have a lot of relationship between objects. Things like, for example, take a password and confirm it with another field, which is confirmation password. You don't need this stuff anymore. It already exists in MVC3, right? It's the compare attribute. You put compare, and you say what you want to compare it to, for example, in this case, name, and it would do that comparison. And that has built-in client-side. So if you're doing things like that, you don't need to implement an iValidatable object, okay? Now, the one thing that it does allow you to do is the plugging in your own validation mechanism. And anybody heard of fluent validation? That's a very nice library which allows you to separate out the validation of a view model from the actual view model. Now you could do that as well, but instead of declaratively, you're using code, defining a fluent interface. So for instance, this is a project I'm working on, and I have a guy over here. So I have, for example, the user registration view model, right? So, hold on. Account update view model, full name, Twitter, and email address, for instance, right? Now there's no actual validation attributes on there. There's no required for all of the different fields. That is delegated to classes where you have fluent validation for defining the rules. So I create a validator for my model, and I say rule for model.fullname should be not empty. And then this goes, you know, it has a whole lot of other options. So you can say, for example, it's an email address, or it has to be greater than some value, etc., etc. One of the cool things about this is that out of the box, if you don't define your own custom messages, so if you just leave the default messages for fluent validation, it already has localizations for 8 languages. So you don't have to actually translate anything. And to use that, you just plug it in. So into the MVC application, somewhere there. Actually, I have that in startup. MVC setup over here. So you see that I'm using the data annotations. Data annotations, validation provider. I'm creating my own validator. Fluent validation model provider, there. I'm hooking it up in MVC, and now I can override the validation model. And fluent validation is actually very, very nice, because as I said, apart from the 8 languages that it supports out of the box, it allows for a very nice fluent interface for providing validation, and it keeps your view model code separate from the actual validation rules. Okay? I don't know if you guys have any questions. I normally like to make my sessions interactive, but it's very hard when I can't hear anyone. Okay, so model metadata. This is to associate metadata with your models. So you can plug in additional information. That's where the data and annotations are done. The whole required and all that, that's done as part of the model metadata. And you can, as I said, you can hook in your own validation provider, and the dependency resolver allows you to, is also obtainable now from the validation. So if you're implementing your iCustom dependency resolver, you can start to consume it from there as well. So like, see, as I said at the beginning, don't go down the route of doing the iController factory anymore. Use the iDependency resolver, because you can use it in different sections of your application. Okay? In terms of views, what do we have new in MVC 3? So we have the ability to build, render, and test views. So you can actually build a view, render it out as a string, and test it. Would you ever do that? Yes. Anyone else with a yes? How many with a no? Okay, that's the good, you know, good balance of yes, no over here. So, you could do it. It can produce a lot of brittle tests. So the idea that you would do this is, I want to automate this process and kind of check to see the output that's being rendered is correct or not. But, you know, it's going to be quite brittle. So for some scenarios it could be good, but often I don't really see scenarios that would fit better. I would normally do the manual testing anyway, because you normally do ship your applications and you do test them previously, right? I mean, you do launch them to make sure that it works more or less okay. So that's kind of a manual test that still would have to remain. Scaffolding, you've seen this in NuGet. This is not actually new to NuGet. This uses the concept of T4, which is text toolkit transformation, templating, T4. It's got test, it's got toolkit, it's got transformation, and it's got template in there. I don't know in what order. You can customize this globally. So when I do the add controller in MVC, what it's actually doing is using the default T4 templates that are defined in Visual Studio Common 7 in that folder there, the 7 IDE item template. Okay? Or you can customize it at the project level. So you can take those, copy those T4 templates, paste them into your own project under a folder called add controller and add view. And then it will use custom templates exactly for that project and only for that project. Now, with MVC3, you don't have to do that copying. You can use NuGet, and you can use the MVC scaffolding. Have you all seen the scaffolding, right? Everyone that went to the keynote probably saw the scaffolding. That uses the same concept, except that instead of hosting that information under your project folder, you're hosting it in a package which is located in your packages folder under a tools folder for the scaffolding. Okay? But under the covers, it's still using T4. And what does T4 look like? First of all, if you're doing any kind of T4, I recommend to get a plugin. There's 2 plugins. There is one from Clarius Software, which is called, wow, I've forgotten. I don't use it that often. There's another one from Tangible Software, which is free. And the one from Clarius that there's a community edition which is free that allows you to do that kind of scaffolding editing, because it's really ugly. So we go to T4 over here. I could have pretty much opened this up in a text pad or notepad and you would have seen the same thing. This is the T4 code. So basically what it allows you to do is, it's kind of, think of it like the Razor View engine or the ASPX View engine. It allows you to combine some input from environment variables, like for example, in this case, everything you see in here is MVC host controller name. The MVC host is the host which provides us with value like the controller name typed in, etc., or the view name typed in, and we can interact with that. What would be great, and a great petition to sign, is if Microsoft would change this, and instead of using this syntax, they would use Razor, because then it would be much nicer to work with, and they have the built-in editors for it. But this is T4. So what I'm doing here is, when you add a new controller, and you tick the tick boxes that says create the read, update, delete, etc. entries, what it's going to do is add a method which is called create and pass in a form collection. You've all seen that. It passes in a form collection, and then normally what you do is you bind that to a strongly typed object, so you take that form collection out, you delete it, you put your customer view model or whatever in there, right? So what I've done is over here just said, you know what, directly bind to a specific model. What is that model? It's the name of the controller that I'm typing in. And I place that inside the add controller folder, and you see that I also have an add view. And the add views are the CRUDs, the scaffoldings for the different CRUDs. So we have the default ones, which are the create one, and we have the details, edit, etc. And I have another one, which is just one that I've created myself. So when is this useful? For instance, let's say that you do your listings of MVC, your customer listings, and instead of using the tables, you use jQuery table, or you use a jQuery grid. Or you could modify T4 to generate directly for you a jQuery grid and not have to modify it manually each time. Okay? So now when I do an add controller, and I do employee controller, for instance, and hit add, employee controller exists, okay, employee 1 controller, and I do add, I see that I have the employee 1. Of course, employee 1 doesn't exist right now, so I would have to go and create that. Okay, so that's the difference. And if I do an add view, see that I have create strongly typed views, let's say customer, for instance. And here I have another one. So as I add my own T4 templates, they appear in that drop box. Okay? Now, again, this is MVC, pre-MVC3 tools update 1. Yeah? That's the latest. Have you all got the tools update? Just came out a couple of weeks ago, or last week at Mix. So what it does is now it's got a new window for the add controller where you can select the scaffolding, etc., etc. So it still applies in that sense, but if you're using NuGet and you're using MVC scaffolding, you could do this at a project level with packages and create your own scaffoldings for different types of solutions and put your T4 templates in there and not have to do this manual process each time, okay? I won't stop saying you have to leverage NuGet as much as possible. So, a couple of things about controllers. We have the async controller, which allows us to execute asynchronous processes, right? So, a long-running process. I can now use an async controller, and the way it's done is very simple. I just take my async controller. So it's exactly the same as a normal controller. Difference is that it inherits from async controller. And I have the async controller's action, which I prefix with async, suffix with async. So I do some slow service. This is like calling out to some WCF service, and it's going to call that out. And when the data is completed, it will then execute the async action completed. And the data that I pass in is the parameters that are going to be available in the binding for this action. Okay? So what does this allow me to do? To free up the requests and have my process, that long-running process, done in the background. And then when it's complete, come back to it. Okay? Anybody use the async controllers? Okay. Now, new in MVC3 are the stateless controllers. Now, one of the issues with using a async controller is if I have a long-running process. And also, it's kind of like, okay, it will provide me with certain amounts of scalability. Okay? In ASP.NET MVC, we don't have the concept of view state, but we do have the concept of a session. And session is used to store information about the user. When a user logs in, it's normally stored in the session. We use the session object sometimes. Every time we do session, assign some value, we're using it. Temp data. If you're using temp data, you're using the session. Because by default, again, temp data is a property which allows us to pass information from one request to another. And by default, it uses session. But it's also a plugin model which allows us to change the provider. So for instance, if we want to do temp data stored to SQL Server, we can do it. We can change the temp data provider. But by default, out of the box, it uses session. So the problem is that when I run requests on the same controller, at some point, these requests are going to be serialized because it's accessing the session. But sometimes I don't need session. Right? Sometimes I don't have the need for session. If I have a front page, for instance, on my website that gets hit very high with high demands, I don't need session there. Why should I need it? I'm not storing any information, for instance. Yes, once the user logs into some process and, adds his username and password and goes to the control panel or to the admin part, then yeah, at that point it's great. I do need a session. But in the front page I don't, or in the news section, for instance, I don't. So how can we solve that problem? How can we say, well, I don't want a certain controller to have session and another controller to have session? In MVC3, prior to MVC3, you couldn't. You kind of had to either switch session on or switch session off. Now with MVC3, they've added the concept of stateless controllers, which pretty much means that there is no state. So the requests to a specific controller don't have to be serialized. Okay? And I'll show you how that works. And I'll open a project which is going to show some performance testing for it. So let's go over here. And I have two controllers here. I have the normal home controller, which session state behavior disabled. What that means is that there's no session state now. If I hit this, and you can see that down here, I'm setting temp data, right? So let's see what happens there. So I've actually disabled session on the home controller. And I can go to about, home controller, home about, and I get the yellow screen of death. Why? Because it says a session temp data provider class requires a session, and that's not enabled in this controller. So already, you don't have temp data. Then I have the low performance controller, which basically is the default controller with session state enabled, and I do a thread sleep 3000, and then I just return the view. And I have a high performance controller, which what it does is the exact same object, the difference is the exact same behavior, the difference is that here, again, I'm disabling session state, okay? Now here I have two load performance tests, okay, which is basically I'm running a whole bunch of tests against these two controllers, and it's running like in 1 minute, it's trying to see how many requests can be processed. I won't open it because it takes like 5 minutes to initialize and 2 minutes to run. And if you run this project, which you can after, if anyone wants to get the code, you'll see that obviously the high performance controller behaves better. It's better performant. Why? Because it's not serializing the requests. It's allowing multiple requests to go in. Whereas the ones with session have less hits per minute. Okay? So in case when we want to have a high performance controller that doesn't really need any kind of session state, we can now fine-tune that in MVC3. And we can specify when we want session and when we don't, which is another good advantage in terms of scalability versus the previous versions. Okay? So to sum up, pretty much, MVC has, from the very beginning, where we have the root data, we have the iRoot handlers, we have the iRoot constraints, we have the iDependency resolvers, custom action invokers. We have all these different extensibility points which are normally as interfaces and have default implementations, which we can then take the default implementations and override them when necessary, or if they don't match at all the behavior we want, implement our own by implementing the interfaces. A lot of extensibility points. But what you need to really do when you're creating MVC applications, apart from leverage NuGet, is create these extensibility points that can be shared across applications. And leverage the fact that you can plug in things, especially in terms of action filters, which allow you to not, be in compliance with dry. So not constantly repeating yourself, doing over and over again the boilerplate code. Boilerplate code isn't solved. That problem of writing the same code over and over again is not solved by creating code snippets, okay, or creating a T4 generated file. It's solved by solving the problem correctly, which is applying single responsibility to a class and letting that class handle that, only that thing, and injecting it in where it's required. Okay? That's the main recommendation I would have in terms of when you're creating MVC applications, and of course, also the iDependency resolver. That's the main thing you have to also implement in MVC3, because it does allow more pluggable points, and as the framework evolves, I'm guessing, hoping, that they will add more entry points to iDependency resolver so that we can access it in different places in the framework. Okay? In terms of the pattern, it's a service locator, but it's better than what we had before. Okay? So that's about it. And we've got 5 minutes, which I don't know if there's a microphone and if anyone's got questions. If there isn't a microphone, then I'm here for another 5 minutes. You can ask me some questions. And if not, that's my email. If you scan that, you'll get my details as well. Okay? And I got to show you these slides to stay up to date. On demand. I bet you're tired of seeing these slides, right? But they told us, leave these slides in there. Okay? So thank you.